Good afternoon, class. This is Dr. Mooring. This is the end of the first week, and I've gotten a number of questions about the Minitab assignment. So I figured rather than talk about it or send you an email, I would give you a PowerPoint presentation slash Minitab presentation of what the assignment's requiring. So the first thing I'm going to do is show you the actual assignment and show you the thought process you should go through to address it. And then I'll open up Minitab on a different different data set and see some of the links that you would use to solve the questions. So here's your assignment. If you remember, it's on slide 91 of the Minitab overview. Okay, so I'll just show you guys in a minute. You can see it's asking you to pull up a particular data set. The data set's called callcenterdata.xlsx. XLSX is an Excel file, but if you noticed on Blackboard, we already have it saved in the Minitab form for you. So you could just actually have opened up the callcenterdata.mtb, I believe it is, and that would give you your Minitab. It'll give you your data in the Minitab format. So the first thing you see it says is copy the data into Minitab. And there are a number of ways you could do this. The easiest but probably least efficient way is just to open up the data in Excel, and you would just push Control A to grab all the data, link over back to Minitab and push Paste. And that would actually paste all of your Excel data to Minitab. The other ways you could do it, in case you have to actually convert it yourself, is to go to File, Open Worksheet. And so that's actually what I'm going to do on a particular data set that I have now. Remember, you guys don't have to do this step because we already have it saved as a Minitab file for you. You'll just open up that file. But I'm actually going to open up the Minitab, okay? And you can see, I'll just keep this and let that thing go away. You can see that here, if you look over here, it says File, okay, Open Worksheet. If you go to File, Open Worksheet, and then type in that information or type in the Excel file you saw, it will open it as a Minitab folder, a Minitab file. In this case, Gapminder is the file that I want to open. Okay. This is a data set. It's a whole bunch of data on a bunch of different countries that have been collected for the last 5 to 10 years or so. So when I click Open, you'll notice this first column is country. It lists all 200 or so countries in the world right now, and there's probably a good 100 or 200 variables on these particular countries. You'll also notice there are some stars in the database. Like, for instance, this expenditure student 2006, there's a star here. The star in Minitab represents missing data. And so clearly you see that this data is not a clean data set, but it is a very real data set. And, you know, I'm about a third of the way over it. I'm already on the 93rd variable. So going all the way across, you'll see that there are, I don't know, 220 or so. About 255 variables for these different countries. And so if you were interested in it, you can go to gapminder.org and download their code book, and it'll tell you what all of these variables mean. Okay, so you see it's gapminder.org. But what I want to show for this example is two variables that we'll use just for this example here. One of the variables is called BP_min 2008. And I'll highlight it for you here. Okay, and actually I'll zoom it in for you as well. If you look at it, you can see that this variable represents the systolic blood pressure of men in that particular country on average in 2008. Okay, and we're going to use this variable, and I'm also going to use this BMI variable which stands for body mass index. And so you'll notice that a comparison of these two, it kind of makes sense that these two will be related. The lower your blood pressure, probably the lower your body mass index, because you're probably more in shape. So we're going to just look at those two, and I'm going to go through a couple of the examples that your assignment is asking you for. So the first thing it's asking you, we'll go back to the Minitab exercise, display the distribution of average handle time for the business. Now, when you open up your data set, you'll have to find that variable AHT business. And one of the first questions you have to ask yourself is, what kind of data is it? Is it numerical data? Is it categorical data? And you'll notice quickly, since we're dealing with numbers and they have, you'll have interval or ratio data, you say, okay, I know that this is quantitative data. So when they talk about the distribution of quantitative data, you know that you want to look at a histogram. So one of the ways that you can display the distribution of quantitative data, and the way that they're requesting in this case, is to create a histogram for that variable. Again, I'm not going to do it for your variable, but I am going to do it for my variable. So in this case, I am interested in the display of body mass index. Okay, so I'll go to BPI min. At some point I'll be able to find it. It's actually it's variable number 190 or so. So I'll look around the 190th line, and I should be able to find body mass index min. Okay. Oops, I went a little bit too far here. Not far enough. Let's see. Okay, let's get that out of the way. Okay, so while I go to find the body mass index one, we'll show you, in order to make a histogram, you have to go to graph. Okay? And you see here, there's a histogram, and we'll click it. Okay. So in this case, I'll just do a simple histogram. I'm not going to put any other fits on it, just so you can see what kind of distribution that particular variable has. So now I get to look for this body mass index min somewhere here. Here we go. BMI min is actually C35. Select. Okay. So we notice that once I've selected it and put it in this histogram folder, you have about 5 other options. One of which is labels. Okay, and in the labels tab, you can actually provide information for your title or your subtitle. So in this case, I think I'll just provide a title of body mass index of men. Okay, and then also you'll notice that there's a subtitle. I'm not going to include a subtitle because this is just, like I said, it's just an example, nothing special. Data labels. You can actually label each country, but since we have about 200 countries, I'm not going to do that. Just click OK. So that's in the labels group. Scale lets you decide if you want to have axes and tick marks. This is a lot like the graphics on Excel, where you're kind of customizing the actual graph that you've created. I have no interest in that, so I'll leave that alone. Data view, you can have bars or symbols. We can also smooth the distribution if you wanted to, or look at the area display. I'm going to leave it on bars because that's typically what you'll see anyway. Okay. Multiple graphs. If, for instance, I were looking at multiple values, you could put all of them and put them either on the same graph or separate graphs. In this case, I want them all on. It doesn't matter if I leave it on same graph or separate graphs because I'm only looking at one variable. So I'll leave that as it is. And then data options, if I wanted to just look at frequencies, like a weighting variable, I could choose the frequencies. But since the actual value is what I'm looking for, I'll leave that alone as well. I'll click OK. And it'll think for a minute or two. And here is your histogram that you'll notice. You'll notice I have a lot of data here, and the lower part, and then it shoots out far to the right. Okay, this would be considered a right skewed or positively skewed data set. But you can see it's kind of a hump here, another hump here, and it shoots back down. And so one of the things you'll notice, I'll actually copy this picture here, and I'll paste it to a PowerPoint slide so that we can actually discuss it. Okay, so you'll notice when you look at your graph, is it symmetric? Is it skewed? Okay, if it were symmetric, if you folded it along the middle, you would think that they were pretty much the same size, or the same things looking back at you. In this case, we clearly see it's not symmetric because you have all of this data up here, okay? You have all of this data here, but you don't have any data on the other side. So I'll kind of give you a pin here. Oops. Here you go. So here's all this data on this side. All right. Here's kind of the middle of your picture, and there's almost nothing until you come out here. So since you have all of your data for the most part on the left side of your middle, or in this case your mode, then you would say no, it's not symmetric. Okay? So that's one thing you can see relatively quickly with a histogram. The other thing you'll notice, well, let's keep it for now. The other thing you'll notice is the next question is asking for descriptive statistics of central tendency measure variation. And so I'll actually go back in your presentation and show you the central tendencies that we're looking for. Okay, we go back to probably about slide number 20. You'll see mean, median, standard deviation, max, min. Okay. All right. And so let's calculate some of those. If you go back to your Minitab and you still have your variable, okay. In this case, we don't want to necessarily graph it. We're looking for statistics of the graph. So we'll click Stat, and we really want basic statistics. So I only want to look at the descriptive statistics at this point, and the variable that I was interested in again was body mass index of min in 2008. So I'll select that. Okay. Again, there's additional variables here, additional choices. I could create the histogram directly from here, or put the normal curve on there, or maybe even box plots of data. I think I'll actually put a box plot on this one, so you'll see what we have here. And then statistics is the box that we really are paying attention to, because mean is checked already. You can get a trimmed mean. It's like if you knock off the top 5% and the lowest 5% and then calculate your mean, you'll have a trimmed mean. You have your median, which is actually checked, which is the 50th percentile. The first quartile is 25th percentile. Third quartile is 75th percentile. And as you guys remember, the interquartile range, if we check that box, is Q3 minus Q1. Or for the most part, it's the median of the middle part of your data. Okay, so we have some statistics of central tendency, mean, median. Okay, and we also have some statistics of variation, standard deviation. I'm going to choose variance as well because the variance is just the square of the standard deviation, and then I'm going to choose the coefficient of variation, which you'll remember is the variance divided by the mean. And I think that's about all I want. Oh, and also the range. This isn't necessarily a measure of variation per se, but max minus min gives you a length of the data set. So in that case, you can see how spread out the data is. And so you notice we have max and min already. When we click OK, you'll notice the range will equal max minus min. Let's click OK, and then click OK again. But I'm not just going to do this for body mass index. I'm also going to look at the other variable that we're interested in, which is blood pressure. So we'll look at blood pressure for men as well as body mass index. Nope, shouldn't have put it there. Okay. Let's get rid of those and try it again. Body mass index and blood pressure. Okay. Oops. There's your body mass index, and there is your blood pressure. Okay, statistics, we still have everything we want. Click OK, and OK. And you'll notice I have 2 box plots, okay? And then I also have my data I'm requesting, which is the descriptive statistics. Body mass index gives you the mean, right here, 24.9. The trimmed mean is 24.952. Okay. The standard deviation is a variation. The variance is a variation, and the coefficient of variation is a large variation. Now, the coefficient of variation pretty much tells you how the variance varies as it relates to the mean. If we had a small coefficient of variation, we noticed that our data was really, really tight together. But since we have a very large coefficient of variation, it's clear that our data could take any number of values. And so when we look at our box plot here, you can see that we even have an outlier on our body mass index. Someone's 34% body fat. And we also notice that our median line is skewed towards this outlier. If we hover over our box, it will show us what our first quartile and third quartile is. And if you subtract those two, again, you'll get your interquartile range. It will also give you your inner and your outer whiskers. Okay, you know that Minitab doesn't actually show the whiskers, but some of the software do. And you'll see the median. Now, if you compare your median of 25.4 to your mean of 24.9, we'll notice that the mean is actually a little bit smaller than the median. Okay, so think about that. Think about what that will do for your actual distribution of your data. Then we also looking at the blood pressure. Okay, blood pressure is this box here. This looks a lot more normal in my opinion. You have a pretty solid box with the interquartile range here. Okay, and the mean, or I should say the median, excuse me, is actually almost exactly in the middle of this box. And the two whiskers are about the same size coming off of the box, and there are no outliers. So the blood pressure of the men is pretty much a normally distributed data set. Okay, and later on in the week, later on in the semester, we'll understand what we mean by a normal distribution. But here is our descriptive statistics that we're requesting, as well as some bonus charts or some bonus graphs just for some kicks and giggles. Okay. Now you go back to the next part of the assignment. I'll slide back to 91. It says, on a single graph, display this average handle time for sites A, B, and C. Okay, this one I will not be able to do for you because our data set, which is the Gapminder data set, does not have a categorical variable on it. Okay, so you'll notice that if you go all the way across, I'll open up our data set again. If you go all the way across our data, you'll notice there are no words on here. So there is no grouping variable I could use. However, you would do the grouping variable the same way you would do the other variable. So you know, if you're looking for handle time, you know again it's a quantitative variable. Okay, and you look again and see what exactly it's looking for. Display the AHT for sites. Okay, that's fine. So you can look at quantitative variables, graph, okay. I can look at histogram again. Or I can look at a dot plot. I can look at a stem and leaf plot. There's a number of these. I can look at a number of these. In this case, I'm just going to include the histogram again. And you can see a simple one, right? Click OK. And then this one has a multiple graphs here, okay? If I were doing multiple variables, I would use this link here. But since I can't do that, I need to choose a different option. Okay? Go back to graph. Okay, you can say histogram again. With outline and groups. That could give it for you. So here, for instance, you would graph your variable here, and then you have a grouping variable or a categorical variable here. And that would actually create a graph for each of those variables. Again, I can't do this for you because I don't have a categorical variable in this particular data set. But you will know that it's possible to do. And you'll also notice that there's those same options for a multiple histogram, as well as if you're only looking at one. Okay. Next, create an appropriate graph that shows the frequency of call types. Which call type occurs the most? Okay. Now, I will tell you this. Call type actually is not a quantitative variable. When you look at your data, you'll notice this number, there are words. Okay, and the words represent groups or buckets of different calls, whether it's customer service or a complaint or whatever. These are not actual words, so you can't do an average or a mean or anything with them. But you can group them and find out about how many or what percentage of your calls fall into a particular group. And so if you remember back in our overview, when we have non-categorical variable, or non-quantitative variable, also called categorical or qualitative, we have to use bar charts or pie charts, and we do not use histograms. So in that case, you would actually go up to graph, you look up bar chart, and you can use this one, which we're looking at one variable at this time, and click OK. And just choose the variable you're looking for and click OK, and you'll have the frequency distribution of the AHT that your question was asking you for. Your call types. I'm sorry about that. Okay. The fifth one, the relationship between occupancy and speed of answer. Again, you need to look at the type of data. Okay, the questions I want you to get to the type of data to determine the type of chart you should be using. Okay, I'll leave it to you to decide what kind of a variable occupancy and answer is, but I will do a similar one for my data set. Again, I'm interested in the relationship between body mass index of these different countries on average and the blood pressure of these men on average. Okay? And so if I want to look at the distribution by country, I am going to look at a scatter plot. Okay? And the scatter plot, I don't have separate groups per se. I want to look at all the groups at once. So I'm just going to use the simple scatter plot and click OK. Okay? And my Y variable, I believe body mass index is going to be affected by blood pressure. So it's possible you could look at the argument the other way as well, but in this case I want to look at body mass index on the Y variable and blood pressure on my X variable. That's pretty much saying that if I know what my blood pressure is, then I know what my body mass index is. And you can make a very good logical argument for the exact opposite that says if I know my body mass index, I can pretty much predict the blood pressure is going to be high or low depending on whatever you come back with the body mass index. In this case, though, for illustrative purposes, it doesn't really make a difference which one you call X or which one you call Y. I'm not going to choose any of these choices down here because this is not a final product. Just kind of giving you an idea of what you can do. Click OK, and you'll notice there's a scatter plot. Now, I'm going to copy this scatter plot and actually put this one also on PowerPoint, just so you can see what happens. Well, it looks like they're not trying to open up another slide for me. So I tell you what I'll do. I'll just open up a new window. There we go. And for some reason, we're not actually able to change. So I'm just going to change the background of this one too. And paste it. Okay, so here's my scatter plot. Remember what happened with our notes. If our scatter plot goes up and to the right, then we'd say it was a positive relationship. If it goes down and to the right, we would say it was a negative relationship. And if it was pretty much kind of no pattern at all, we'd say it was pretty much a zero relationship between those variables. Well, with this number of variables, it's kind of hard to determine is there a relationship or not. But it looks like, this is just kind of eyeballing it. It looks like there may be a slight, at best, positive relationship between these two. More than likely, it probably is the case that it looks like it may be no linear relationship. But if you can imagine where my picture is, maybe something like this could be the best case scenario between them. But somebody else may look at this and actually look and say, hey, this is actually the best fit line. And if this was the best fit line, this is positive. Okay? But if this was the best fit line, it's not positive. It's pretty much a zero. So, looking at this scatter plot by itself, we really can't tell if it's positive or not. What we can do, now your assignment didn't ask for this, but what we can do is actually plot the best fit line onto the scatter plot, and it will tell us if it's positive or not. So let's just do that just to find out if in fact there is some positive relationship between them or not. This third choice, with regression, we'll actually put the line on there and click OK. So again, we'll choose our body mass index as our Y, and we'll choose blood pressure as our X, and click OK. So we have that same chart, and you'll notice that the graph is pretty much straight down the middle. So there's actually very little correlation between body mass index and blood pressure. And this is kind of surprising, and in a way it's kind of not surprising considering the body mass index was actually a symmetric or approximately normal variable, which means it's kind of like whatever happens with blood pressure, you're going to have some who are high body mass and some who are low body mass. But looking at this data here, you say, oh, there's no real relationship. Surprise, surprise. Okay. Now the last one, okay, let's go back to your assignment. On a single graph, display the monthly average call for A, B, and C. This is actually a time series analysis. And again, in my data, I don't have an example of a time series analysis to show you. But what I can do is show you what you would do to do it on your particular data. If you go to Graph and then go to Time Series Plot, you have an option for single or with groups. Okay, since they said there was A, B, and C, let's choose with groups and say OK. And so the series is actually the data that you're trying to plot. So let's say, for instance, you're looking at economic aid that was given to countries in 2007. And the categorical variable is actually the one you're trying to break up. So you want to look at it differently for Europe, different for Africa, different for North America. If you had a categorical variable that provided that continent, you would put it here. And then I want to know, is that A differing over time, over years? Well, if I have a time variable, let's say 2001, 2002, 2003, I would use that as a stamp. Okay? So I can take that time stamp and put it here. In your data, you have a month stamp that actually tells you it's January, February, March, April, May, etc. That is your stamp. And you would want to put that at the bottom because that becomes your x-axis. If you do not, you could use calendar, or you could use an index, you could use just a clock, okay? And where this will just give you a time over every hour or every minute or second or day hour or what have you. Once you get those in, you just push OK and you'll get a time series plot. I'll give you an example of what it looks like. This is actually one that you would possibly come up with because it was using your data. Yeah, let's save this. And we'll call this one Gapminder data. Okay. So I'm going to open, this is that quality one. Okay. You'll notice that you have your months at the bottom. You'll have the actual value you're interested in as quality here. And because we did multiple, they have different values or different colors for site A, site B, and site C. Your data you're looking for will be C23, C24T, and C25. And this would pretty much be a combination of everything that you need to do for your Minitab overview. So hopefully, I've given you guys a flavor of some of the things you can do with Minitab, as well as things that you could analyze or interpret or see kind of the usefulness of having a statistical software as opposed to Excel to do statistics work. Excel is fine for simple spreadsheet calculations, but as we go on with the rest of the semester, you'll find that Minitab and other software like SPSS and SAS have actually been designed to do exactly the kinds of things that we'll be doing in class today. So that's going to end this particular video. Hopefully this kind of helped explain some more as to the idea behind that Minitab overview assignment. Now I do realize that there was some difficulty in determining where to upload the data and trying to make it by the Sunday deadline. Let's go ahead and extend that deadline, and you'll have until 11:59 p.m. on Wednesday to get this turned in to me. So this is a graded assignment. It's going to be one of your 18 assignments. If you look at your syllabus, you'll see that there's one Minitab overview assignment. There is a signal processing assignment. There's another third assignment, and then there's 15 chapter reviews. So that makes up the 18 assignments, each worth 20 points each. So that is going to do it for me. Enjoy the rest of you guys' Labor Day, and have a great day.